Hello, everyone. Welcome to today's webinar, Powering Data-Intensive Applications with Spark and Single Store. My name is Diogo, and I'll be your moderator. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A function in the lower right corner of your console. We will answer everyone's questions after the presentation. After today's webinar, you will receive an email with a recording. If you wish to contact us, please email us at team@singlestore.com. So let me introduce our speaker today. We have Sarang Tripathi. He's the Principal Solutions Consultant at SingleStore. Welcome, Sarang. You now have the floor.
Welcome, everyone, and thank you, Diego. So today we're going to talk about powering data-intensive applications with Spark and SingleStore and why speed really matters. And then we're going to really get into the nuts and bolts of how Spark and SingleStore work together for enriching cloud customer experiences. So let's just start with sort of why why we're even here today and why we're discussing this. So typically when we have data-intensive applications in the cloud, that have bottlenecks, we start by identifying where those bottlenecks are in order to enrich those customer experiences. And typically when we start those, we start by refactoring at an application layer. We change different application level things, and then when that doesn't work, we get into really the ETL processes to try to improve the data processing and data ingest portions of our performance issues when we're talking about data related applications. And then after getting into applications and getting into the ETL layer, we say, maybe it's time to performance tune the database. So we go through database schemas, we go through redesign, we maybe go through sharding exercises or scaling exercises, things like that. Then we potentially manually shard a database. And then after all of these steps, then we think about migrating to a new database. So you can see this is a very, very long and grueling process at times. In addressing performance issues in the cloud. And so what typically happens is, or what's happened in the past is that we end up having very disparate data and slow applications based on this. So we have many different data sources of a streaming, of a batch nature. And in the past, we've put them into places like Hive and HBase and SQL Server, Exadata, et cetera. And we've moved that data around quite a bit. And what's happened as a result of moving that data around is that we have bottlenecks at each of these places. So the streaming ingest becomes a bottleneck. The batch ETL windows between our data warehouses, our data marts, our data lakes, and then all of these other legacy databases ends up very long. And that ultimately leads to query latencies on the data warehouse side, which ultimately really leads to our data consumers not getting those fast applications, those fast dashboards, those fast reports. And so over time, we really tried to solve this problem as data professionals by taking these data sources, the geospatial, time series, document data, key value data, and saying whether it's streaming or batch, let's just put it in a bunch of different types of single purpose databases. And at the time, it seemed like a good idea with things like MongoDB, like InfluxDB for time series data, Snowflake for relational data, and then perhaps Redis for key value store. But ultimately, what happened is we encountered this problem of what's called database sprawl. What really happens in this scenario is that you still have a bunch of databases, you still have a bunch of data sources talking to each other and moving data across one another, and there's no real single point to access those from a consumer layer. That application layer, the data science layer, the reporting layer is still tying into multiple different data sources out there, and that's becoming still a problem. You're still going one place for your document data, one place for your time series data, et cetera. So what SingleStore offers is the unified database for these data-intensive applications. And the way that we do that is by combining the world of transactional workloads, those operational database types of features, where you need fast lookups on highly concurrent workloads, along with the analytical side, which is more of your data warehouse. You still need your fast queries, but you need to do large data set type of aggregations. And so what SingleStore does for our user base is simplifies the support of diverse workloads by reducing complexity of that. And we do that through our patented universal storage technology, which blends a row store and a column store together to give you a place to have transactional analytical workloads run together in one database. And so over time, single store actually, we started as an in-memory row store and added in this disk-based column storage. The row store was initially really good for OLTP and those highly concurrent updates, the millisecond responses. And then what we realized was that we also wanted to add in a way for our customers to store lots and lots of data with a very low TCO. And so we developed our column store, which was really good for OLAP, those billion and trillion row workloads, with very high compression rates to really drive that TCO value for our customers. And then what we've done in the last few years is actually combine the two of these into our patented universal storage technology, which is a simplified architecture. There's much lower TCO involved with this and much lower latencies when you are using our universal storage mechanism. So this is truly a combination of the row store and the column store, from dual store to single store. So what this really enables you to do is maintain that ultra-fast ingest with this high-scale streaming data ingest of billions of events per second, thing like with our customers like Akamai are doing, bringing data from Kafka at millions and billions of events per second for immediate availability within data-intensive applications. And then that super low latency. So once the data is in, you still need to be able to get it very fast. And that's another place where single store really benefits the customer. And then at highly concurrent workloads. So it's not just important to have the data in very fast and the data accessible very fast, but the data should be accessible to very large amounts of people, tens of thousands of users at one time, with that unparalleled scalability for single store users. And what this really gets you is this fast analytics on dynamic data for those applications. So let's just dive in a little bit deeper now about what we're really here to talk about, and that's Spark and single store. So you've heard about single store today. Now let's talk about where these two technologies play very well together. So Spark is used, as I'm sure many of you know, to move data around across different applications, different systems, different data sources, as well as run complex machine learning models on this data. So what we've built here at Single Store is our Single Store Spark connector via Spark's data source API to leverage existing models in place that you may have in Spark or existing data movement mechanisms that you have written in Spark. And then what we do is we push down anything that you've built in Spark. Perhaps it's built in Python, perhaps it's Scala or Java. And we're leveraging the speed, the scale, and the compute of single store in order to enable faster running of Spark. So our customers see, in some cases, 20x improvement on some specific supervised learning models that they're running just by taking them from Spark, enabling push down into single store, and then running those models. All applicable Spark data frame operations will get translated into SQL and then executed against single store using single store's compute. So together, this really gives us the fastest data platform for both integrating data, both moving data, as well as that analytics and machine learning on top of that data. Here are just a few features of the Spark connector. The Spark connector is a true Spark data source compatible with the JDBC Reader and Writer API. It's implemented as a native Spark SQL plugin, and what we'll show you today is robust SQL pushdown support, in addition to partial pushdown. So what that means is, if I have some Spark syntax and single store says, okay, I can't push down all of this workload to single store, but I can push down part of it, it will smartly and dynamically do that onto the single store compute layer. And this will take advantage of all the latest and greatest features of Single Store 7.5. So for example, in Single Store 7.5, which we'll talk about in a little bit, we've separated storage and compute. And so the compute layer will be leveraged by the Spark connector directly. So what does this really enable us to do? It enables us to build those smart data intensive applications that we're talking about. So instead of that old data movement type of and really constricted way of handling data intensive applications, we can still now take these streaming batch and operational data sources, process them with Spark streaming, as well as any other data source like S3 or like Kafka. And this is something that our customers, such as Uber, such as Hulu, are doing, leveraging Spark streaming to bring in those data sources, leverage the Spark connector, as well as single store pipelines to bring data into single store and have those unified AI-driven customer applications. Because with the power of a data source that is as fast and as highly concurrent as single store is, with something like Spark that can be so AI-driven and ML focused, you really get these smart customer applications for your end users. The next use case here is augmenting existing applications. So we've talked about how to bring in data and process data using the Spark connector, using the Spark streaming, using single store pipelines. But this isn't just for building your smart applications. It's also for augmenting the other data infrastructure that you have out there. So for example, you could be using Databricks Delta Lake or Google BigQuery or Snowflake even, on top of technologies like S3 and Azure and GCS. And perhaps you need another layer on top of those because your applications aren't performing fast enough. This is where single store also comes in to augment and to accelerate those applications. You still may need your Snowflake and BigQuery, et cetera, to hold long-term data, but single store can be that place on top of Snowflake to augment and to accelerate those applications and keep your overall IT infrastructure TCO very low. So let's talk about a little bit about single store in the cloud specifically. So single store is offered in the cloud in two different ways. One is the managed database as a service, and one is our private managed service, which is newly been renamed to our dedicated offering. And it is cloud agnostic. So the managed database as a service can be deployed in AWS, Google Cloud, and Azure. And we're also certified against Red Hat's cloud as well, if you wanted to do that in the dedicated managed service. Let's talk a bit now about the new capabilities, some of which you'll actually see today. We recently had a very large product launch on June 21st, and this is our single store 7.5 release. So this is really focused on three areas: our mission critical nature of single store, technical innovation, and then ease of use. So around mission critical, we've introduced point in time recovery and a number of new security and compliance related certifications, all of which the badges you'll find on our website. Technical innovation. So I mentioned separation of storage and compute. You'll actually see that today, wherein you'll see that the compute now within single store's managed service is separate from storage, and we have unlimited storage capabilities now, such that after data hits disk within single store, it's also flushed to S3 in the case of AWS. So you have full separation of storage and compute and an unlimited storage mechanism. We've also iterated further on the universal storage capability within 7.5. Ease of use. So you'll see today the ability to suspend and resume clusters. This really helps your flexible billing model. So if you only want to use single store at certain times, perhaps when your workload gets a bit heavy, or you want to turn it off and turn it on at certain times of day, this is what that'll enable you to do. So a bit about the responsibilities for single store managed service. So we actually at single store handle everything in the managed service, from cluster provisioning to deployments to upgrades, managing the cluster, alerting on that cluster, troubleshooting on that cluster 24/7. We handle all of that. And so you do not have to have the headache of managing your database when you use single store managed service. All you are responsible for is the logical management of the data. What that means is, and you'll see me do this here in a little bit, is creating your pipelines, creating your tables, creating your schemas, and writing your queries. That's all you have to do. You get to do the fun part of dealing with a database, and we do the hard part. And so what this enables you to deliver, what we deliver to you and what you'll in turn deliver to your customers, is that effortless deployment and elastic scale, one-click scaling in the managed service. That pause resume gets you that superior TCO versus legacy databases. Things like compression get you superior TCO versus legacy databases. We are multi-cloud, so you're not locked into a AWS RDS or an AWS Redshift or a GCP BigQuery. You're not locked into anything like that. We are multi-cloud. So if you want to be on AWS today and Google Cloud tomorrow, we can help you do that. And this really gives you the speed and agility to run your business how you want to run your business. So with that, I'd like to jump into a quick demo of the managed service and Spark. So I'm going to jump right into the Single Store customer portal. So if you sign up on singlestore.com/free, you will sign up and you'll jump into this screen, which enables you to create database clusters in the cloud. And so typically there will be in the center of the screen, there will be a button that says create managed cluster. I have already created a managed cluster, so I don't see that, but I'm going to show you how you would do that for yourself. So you would go through here and say create a database cluster. You would say the name of your cluster, where you want it to be, and then as you can see here, compute and storage are separated in our managed service now. So you would select how much compute you want, and the price for that compute will be listed here, though your trial will come with $500 in free credits. So you'll get to select which tier of compute you'd like, and then storage is here as well. So you'll only be paying for the amount of data that's stored in your cluster. So you'll select a password here. It'll automatically define your IP address, so you're only allowed to access from this specific IP, and then you can go ahead and create your cluster. So now that I've done that, I'm going to just skip into a cluster I've already created. So once your cluster is created, you'll be here and you'll be able to get into interactive tutorials, solution guides, and our 100% free self-paced training that's on our website. If you'd like, you can add in more firewall rules. You can configure more security parameters. So if you want to secure outbound connections versus with TLS and SSL, you would upload those certificates here, and you have clear details on how you would create pipelines to places like Kafka with that. We also have full monitoring within Single Store Studio. So you could come in here and look at how much CPU is being utilized, how much memory is being utilized. And you can look at that historically as well to understand the health of your cluster, how many pipelines you have, all of that kind of stuff. So I'm going to go ahead and actually sign into Studio because I'd like to show you a few things. And this will load up. So this is just going to show me the cluster health and cluster usage, as well as some of the pipelines that I have. So I've gone ahead and preloaded some data into this database cluster. And what we'll see here is our single store pipelines in the bottom left-hand corner. If I go ahead and view those, you can see that I have a number of different pipelines. One has failed, likely because there's no data in the S3 bucket, but you get to see that there's full monitoring of why those pipelines failed. And then you can see the ones that succeeded and how many batches, how many rows were written in each batch of that pipeline. I could also go in here and look at my databases and look at my specific database. Today we'll be talking about the TPCH data and then in all the columns associated to that, as well as everything that's going on my cluster right here. So if I jump in back to the portal, I'm going to go to my SQL editor. And again, I mentioned we're going to be looking at TPCH benchmarks today. And so all I have to do is, and by the way, I should mention that this tutorial is all within our portal right here. So if you go to tutorials within the portal, you can say query a sample data set, benchmark data set, and then go through this entire tutorial on your own. So if I just create my database and then I use my database, I'm going to create a number of different tables here. If you're not familiar with Single Store, you'll see some syntax here that says shard key. This is going to dictate how your data is distributed across your database cluster. And so this is really important to making sure that you get lightning fast queries. So I've created all the tables for my TPCH data here, and now I'm going to create some pipelines. And these pipelines are simply stating, hey, go out to S3, pick up the line item data. This is where the S3 bucket is, and get that in as fast as possible. You can see here, even on the smallest cluster size, I'm loading in 3.6 million records per batch, and my batches are coming in, every couple of seconds. So I've got a ton of data in here. I can even do a select on this data set to kind of look at how much data I have. And if I go ahead and do that, I can say select count star from, I believe the table is just called line item. And I have to select my database, so I would come up here and do that. And you can see I have, at this point, 4.3 billion plus records in my single store database. And this is leveraging our bottomless storage, that unlimited storage mechanism that allows you to just continue pouring data into the single store cluster and to no end. But now that I have this data in, let's really do something fun with Spark. So I'm going to open up a Jupyter notebook here and walk you through what I've done. So all I've done to start is just start off Spark. So I just do a packages statement here, bring in the single source Spark connector. You can get this on GitHub, and then I'm going to open up a PySpark shell. I'm also going to import MLflow because once I build this model using Spark and single store, I want to save it as well. So after doing that, I'm going to import PySpark, and then I'm going to actually start. Start a Spark session here by saying get or create, and then I'm going to connect. So I have my DDL endpoint from single store, and I can actually go show you where I grab that. I grab that by saying connect right here, and if I just go to endpoints within the single store portal, I can grab the endpoint and drop it right here. And then I just give my username, I give my password, and then the most important thing that you'll see when configuring the Spark connector is saying disable pushdown is equal to false. So let's talk a little bit about what this means in terms of Spark and single store. So we talked earlier about what pushdown is and how we were able to take Spark data frame operations and turn them into SQL and run them into single store. When I say disable pushdown is equal to false, this means that pushdown will always be enabled, and everything in Spark that can be pushed down into single store will be pushed down and will leverage the compute of single store. And that's what I want. That's the behavior that I want here. As you can see here, I also have a query. So I'm just saying spark.read.format, and then I'm using our single store, formerly known as memsql format here. I'm loading that tpch.lineItem data, and I'm selecting a number of columns here. As you can see, I'm just going to go ahead and select. I'm just going to go ahead and select 1 million records to train with. It's just going to be super straightforward, and that happens in 380 milliseconds. And then I'm going to just do some simple feature engineering on. I'm going to take the discount column. If there are no discounts, I just want to fill it with 0 for the discount. Now I'm going to define my features vector with a vector assembler within within Spark. So I'm doing that, and then I'm just going to split up my train and test data. So I'm going to do a random split 70-30, just as you would typically do in any sort of machine learning model, and then I'm going to define my label column. So what I'm trying to predict here in the TPCH dataset is what is my price of a specific item. And then I've gone ahead and run this model, and this specific step I pre-baked because I didn't want to have to wait for the model to run. But as you can see, it's running 44 seconds using pushdown, which is very fast as compared to if you did not use pushdown. If you use Spark to pull the data out of a database and compute the model and then return the results, this would take many minutes, if not hours, to do. So we've created a model under a minute here, and then we're evaluating that model under 30 seconds. And I have now an R-squared value of 0.86, which we can say is reasonably good. I can then go make predictions on that test data now. So you can see what I've developed here is a predictions column using all of these other columns here to predict a certain part of that data set. What are the prices of those values going to be? And then I can go back here into MLflow and save that model back into my file system. So this really hopefully gives you an idea of how to leverage Spark Pushdown to run models. We also have several examples on our GitHub where you can not just run models, but you can compare how do you run models using Pushdown, not using Pushdown, see how those two compare, as well as doing the same for ETL jobs or loading data into single store or bringing data out of single store. I can do all of those things with the Spark connector. And with that, I would encourage all of you to try this for free today. So please come and join us in trying the single store managed service for free. We offer $500 in free credits. You just go to singlestore.com/manage-service. You can even go to singlestore.com/free. And if you contact us at managed@singlestore.com, that comes directly to my team, and we can certainly assist you with your trial and get you started and get you and sort of technically validated with the technology. Thank you.
Thank you, Sarang. We will now begin the Q&A session. As a reminder, the Q&A function is in the lower right corner of the GoToWebinar console. We have one question here already. What other kinds of models can you run against single store than what you've shown today?
That's a fantastic question. So, what we've shown is linear regression as well as gradient boosted decision trees. And if you're familiar with machine learning, these are both classified as supervised learning models. And so many other different types of supervised learning models are things that you can run inside single store. We're also doing testing on running certain types of unsupervised learning models as well, and there's some support for those as well. But it's primarily supervised learning that users use Spark and single store for.
Awesome, thanks. The next question is, can you explain Spark Pushdown?
Sure, yeah. So as we discussed a bit earlier, so Spark Pushdown is what really is happening within the Spark connector. Is it's taking those data frame, using the data frame API, taking those operations that are happening within there, and then literally translating them to SQL. So a great way to check this out if you're testing out the Spark connector is to go into the workload monitoring tab of Single Store Studio and monitor the entire workload, and it'll actually give you a point in time view into all the queries that are running in Single Store. And so if you take something in Spark that you're doing and then watch how it's executing within Single Store, you'll see that everything is being converted into a specific SQL query inside Single Store, which is really where the power comes from.
Thank you. Another question here is, how does the scaling work in the managed service?
Great question. So I can actually pop back into the Single Store customer portal and show you. So if you wanted to scale your cluster, all you would need to do is click edit right here in the portal, select your size that you want to scale to, and then just say update size. It's a matter of a few clicks. And in our Single Store roadmap, we also have a scaling API that we'd love to deliver to our users at some point to enable you to scale programmatically as well.
Thank you, Sarang. It looks like we don't have any other questions. Let's give everybody a minute. Okay, we have one actually. Are we required to have that database user account created from all nodes for Spark loading?
Sorry, could you repeat the question one more time?
Yeah, sure. Are we required to have database user account created from all nodes for Spark loading?
So as long as that's a good question. So for loading data, you would have to have the whatever access a user would need to load data in any other way to Single Store. They would also need to be able to do that via Spark and their credentials, which in this case I used admin. Whatever user credentials that they have, would need to map back to being able to load data into single store in any other way too. It's not, the Spark connector is no different than any other sort of access credentials that you would have in any other way to access the database, since you're simply just using the same endpoint that you get within Portal.
Thank you. Let's give everybody a minute. So if you have any other questions, please drop on the questions panel. And if not, we're going to close up the webinar today. Looks like we don't have any more questions. I want to thank Sarang for the presentation. Thank you all for attending the webinar today. We will send you a follow-up email with today's recording and a link to our managed service free trial. We're offering each user $500 in credit, so you can start a full workload today. Lastly, check out our other virtual events at singlestar.com/events. Thank you for joining us and have a great rest of the day.